In this lesson, we will show how to decompose water into hydrogen and oxygen gases using electricity. This process is known as the electrolysis of water. The electrolysis of water involves passing electricity through water containing a small amount of a salt. This causes the water to break down into hydrogen and oxygen gases as shown in the equation. The result of this experiment proves that water contains twice as much hydrogen as oxygen. The electrolysis of water is often performed using a special apparatus known as the Hofmann Voltameter. The photo on the left shows the apparatus mounted on a standard laboratory metal stand. The apparatus can be purchased online for about $100. The apparatus was invented in 1866 by August von Hofmann, a German chemist. Hofmann's unique apparatus enables us to collect and measure the amount of hydrogen and oxygen gases produced by water electrolysis. The first step is to prepare an electrolyte solution by adding a small amount of a salt like sodium sulfate to water. The electrolyte solution contains ions that increase the flow of electrons through the solution to speed up the process. The electrolyte solution is made by first adding 100 grams of sodium sulfate to a 1000 ml graduated Erlenmeyer flask. Next, add water to the flask until the level reaches the 1000 ml mark. Stir the mixture until all of the sodium sulfate dissolves. This diagram shows the various parts of the Hofmann apparatus. The center tube has a reservoir at the top for the water solution. There are two long tubes with graduations to indicate the number of milliliters of gas produced. Embedded in the bottom of each tube is a platinum electrode. The top of each tube has a stopcock. As shown in the diagram on the left, pour the dilute salt solution into the reservoir. The liquid will travel up both tubes. When the liquid reaches the top of the tubes and goes through the stopcock valves, close both stopcocks. Now connect the electrodes to a source of direct current electricity. In this diagram, we show the use of a small 9-volt battery, but any source of 9 to 12 volts of direct current electricity can be used. In the diagram shown here, the positive electrode on the battery, known as the anode, is connected to the platinum electrode in the tube on the left. The negative electrode on the battery, known as the cathode, is connected to an open switch that connects to the platinum electrode in the tube on the right. If a switch is not available, simply use a wire with a clip at the end that can be connected to the electrode when you are ready to begin the electrolysis. To begin the electrolysis, turn the switch on, or connect the cathode wire to the platinum electrode on the right, to complete the circuit. If using a 12-volt power supply, simply turn on the power supply's switch. Bubbles will begin to appear in both tubes, but there will be many more bubbles in the tube on the right. The tube on the right, connected to the cathode, will produce hydrogen gas that builds up at the top of the tube. In the tube on the left, bubbles of oxygen will rise through the solution, and oxygen gas will accumulate at the top. After about 30 minutes, the tube on the right will show about twice as much hydrogen gas as the tube on the left, containing the oxygen gas. Read and record the number of milliliters of hydrogen and oxygen in the tubes.
Now, let us discuss the chemical reactions that are taking place in the electrolysis of water. The reaction at the cathode is called reduction, and involves a gain of electrons, as shown in the following equation. Hydrogen gas is formed at the negative, or cathode electrode. The reaction at the anode is called oxidation, and involves a loss of electrons as shown in the following equation. Oxygen gas is formed at the positive, or anode electrode. Combining the two half equations from the previous slide, we obtain the following equation. Subtracting the 4 water molecules on the right from the 6 on the left, gives us the following equation. This shows that the electrolysis of water should produce twice as much hydrogen gas as oxygen gas. This photo shows a Hofmann Voltameter apparatus that used a 12-volt direct current battery charger as a power supply. The reservoir and tubes contain the dilute sodium sulfate solution. The power has been turned on, and an actual water electrolysis experiment is underway. Note the large number of hydrogen bubbles in the tube on the right. After the electrolysis proceeded for about 30 minutes, this photo was taken to show how the hydrogen and oxygen gases filled the tubes. Note that the volume of hydrogen gas in the tube on the right is about twice the volume of the oxygen in the tube on the left. The volumes of the gases from the water electrolysis experiment were recorded every 5 minutes, and plotted on this graph. After 45 minutes, the ratio of hydrogen to oxygen was 2.13, slightly more than 2 to 1. The ratio of the measured volumes of the gases is not exactly 2 to 1. This is because the solubilities of hydrogen and oxygen in water are slightly different. Another important feature of the Hofmann apparatus is that it enables us to collect the two gases. This diagram shows how to collect the hydrogen gas. First, place a large test tube over the stopcock on the tube containing the hydrogen gas. Next, open the stopcock to release the hydrogen gas into the test tube. Keep the tube with the closed end up. Hydrogen is lighter than air and will remain at the top of the tube. Now, quickly seal the tube with a rubber stopper or cork. We can show one of the properties of hydrogen by checking its ability to burn. Keep the hydrogen-filled test tube in the position shown in this diagram. Take a thin wooden stick and place the tip in the flame of a candle or Bunsen burner until a small flame appears at the tip of the stick. Holding the test tube in the position shown in the diagram, remove the stopper, and quickly insert the flaming stick into the tube. A loud popping sound will indicate that the hydrogen has completely burned. You may even be able to see the blue flame, but it does occur very fast. One of the properties of hydrogen is that it is very highly flammable and burns rapidly. With the Hofmann apparatus we can also collect the oxygen gas as shown in this diagram. Place a large test tube over the stopcock on the tube containing the oxygen gas. Now, open the stopcock to release the oxygen gas into the test tube. Keep the tube with the closed end up. Quickly seal the tube with a rubber stopper or cork. We can show one of the properties of oxygen by checking its ability to support combustion. Keep the oxygen-filled test tube in the position shown in this diagram. Now take a new thin wooden stick, and place the tip in the flame of a candle or Bunsen burner until a small flame appears at the tip of the stick. Blow out the flame. The tip of the stick should be glowing red. Holding the test tube in the position shown in the diagram, remove the stopper, and quickly insert the glowing stick into the tube. The glowing stick will immediately flare up, showing that oxygen helps to increase burning. Oxygen itself is not flammable, but its key property is that it supports combustion. Therefore, flammable items will burn very rapidly in an atmosphere of pure oxygen. This presentation was produced as a public service to help middle school and high school science teachers develop experiments, presentations, and demonstrations that can be used in their classes. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website at www.topsofscv.org. Teaching Opportunities for Partners in Science, also known as TOPS, is a program aimed at stimulating greater interest in science by middle school students.